lite, så då kommer du höra det. Okay, let's get going. I'm very sorry for the delay. The sound system on my computer decided to not work very well. Finally, I found one input that works, so we'll go with that. My computer fans are going. I hope it's not too distracting. I'm not sure what's going on there either. Welcome. This is a monthly SWEOUG. We did this last month. I think a few people couldn't get in and see it. So we're trying to do it again and see if it works. And after this, I'll try to edit this and make sure that it's available for review for anyone that wants to see it. Let's see. Wrong way. We should do that. Sorry, a little bit stressed out still, apparently. So let's talk a little bit about SQLcl and the scripting capabilities in it. So first a few words about me. My name is Mattias Magnusson. I'm the owner and the consultant of Evil Ape, company I run by myself. I'm the founder and the current leader of SWEOUG, which this is, of course, one of our meetups in the times we're in. They're always digital. We try to keep them at roughly once per month. You can find me at OraDBDev or Mattias Mag at Twitter. And I'm an Oracle Ace. And speaking about Ace, let's talk a little bit about the program. The program has, in this slide, it has 3 levels. I have not seen an updated version of it. And I think the associate is not really part of it anymore. We've moved to having Ace and the Ace associate at the same level, and then we have the Ace director, which are the people that are talking the most about Oracle technology. And there are a few of those, not too many. The Oracle Aces are many more. So if you want to be part of this program, to talk or give presentations, blog, any which way you spread content, you can get in touch with me or with the program directly and so forth. And if you want to know a little bit more what it takes on the different levels, reach out to me, reach out to the program. Over to Aura World. I think this is a very good magazine. I think everyone should read it. The reason is that it's not affiliated with Oracle. It is made by the user groups of Europe, or Middle East and Africa, the EMEA groups. And it has some very good content. Taking a look at some of what it has been in it shows that it goes from pretty technical to overview to just thoughts of the future and so forth. Pretty much what you would want on this. So it should have a little bit for everyone. So let's get over to the scripting or the presentation. What I used to do to prepare this presentation, should we say, is the Oracle Cloud. I was using SQLcl 20.2, and I was using ATP, the Autonomous Transaction Processing Database. That's of course not necessary. What we'll show and talk about here today, you can do anywhere, and a recent version of the database and a recent version of SQLcl. So a few words about SQLcl then. It's a text-based interface for Oracle, for the Oracle database. It is based on the SQL developer, essentially the same code, of course, less the GUI. It is free and it's built by the same team that makes SQL developer. And ATP then, it stands for Autonomous Transaction Processing. To me that doesn't say too much, but it is an Oracle database in the cloud and it's automation in it via machine learning. And you can get your own for free. It's just to set it up. You can actually get 2 of them for free. Where to start with scripting? Well, with just basically anything that is Oracle developed tools. Chris Reich is the man. Here's a link for his demonstration of it. That's online. It's GitHub-based repository. I would say it's unfortunately pretty stale. That could mean that it's very comprehensive, or that he's been busy with other things lately. But it's a good start to see things, and it's a good place to see what can be done to get some ideas of how to go about doing more advanced things, or not, just different ways of managing this. So SQLcl is the command SQLcl, or the object, should we say, is the SQLcl engine itself. It runs SQL just as if you typed it on the command line or on the prompt in the tool. So here we run SQL select star from table, and we run it, and we get the output we expect. We also get the heading. We get all the normal things that we would do. Let's also back up one step here. The scripting we talk about is part of Java, comes with it since it's built with Java. They've enabled it, and what we're looking at today is JavaScript. You don't really need to know it for what we're doing, but that is what it is. The functionality allows for implementing other languages for scripting in the Java layer, and that will be coming in the future. So one popular area is Python. Pretty sure that's on the roadmap, but it's not here yet, at least not in SQLcl. So why would we do it this way? Well, the idea here is of course not to just run a simple statement like this and run it, then we just type it in and run it. So for this example where we run it, we get the headings and all of that. It would be that we would put some logic around it, figure out which SQL we want to run, how we want to run it, or which columns we want to use, or some such, so that we get something that is a bit more dynamic in nature than static SQL would be. And even this layer is not possible with pure SQL. We can run the statement, we can print the output, but we cannot get it so that it prints it the way SQLcl would print it, with all the features it has with the dynamic column lengths and wrapping and all of these things. onto picking up arguments. So here we have a piece of code that loops around over the args variable or array, which are the arguments you pass in a call, and then we just write them out. So here the call is running, script is how you invoke a file with a script in it in SQLcl. We pass in here 1a and 34. The output is args.js 1a and 34. The surprising one may be the first one that has the index of 0. That is a Unix convention that how it was invoked is the name it was invoked with is the first parameter. So that will always be there. And over to the util class of functions. It has a lot of features. We'll look at some that we read data with here. And in this case, we're just looking at the execute one. It executes whatever is passed in with a Boolean return for success and failure. The basic use of this is to perform DDL and know if it succeeded. Or DML, like in this example, with we make an insert to a table that has a primary key. We just want to know if it worked or not. If the key always exists, we will of course it will fail like it should, and we'll get a false return code. And so here we have an example of that. We create an empty array of bind variables. We need to pass them in. It's part of the signature. And a simple insert, just one column, values ABC. If it doesn't work, we'll print out insert failed. And if it worked, we'll print out inserted. I notice here that this slide is wrong, or maybe it could be used to explain one thing that we want to do. We'll talk a little bit more about context-write later, I believe, but on the first printout, it is context.write. That's how we want to do it. It's how to get output to come out the proper way in SQLcl to not be overlaid by other features in the tool. Print here is a JavaScript print command. It prints it all right, but SQLcl is then not aware of it, so it easily gets overwritten when you move around. If you use the arrow up in SQLcl to see previous commands you run, it will very easily overwrite your output that's come out with print, because that's an output that SQLcl wasn't aware of that was outputted to the screen. So always use context.write. Let's go back here and talk about I thought I had output from this to display also, but it doesn't seem like it. Let's see, no. So then talk about this. The first time we run this, it will of course work, and it will say inserted. Second time it's run, it will fail because this column is a primary key, and then we'll say insert failed. Then we'll go over to the next, execute return one column. The text in blue here, I should say, this is Oracle's definition of what these things do. And then after that, I explain how I think about it a little bit, or how I use it, or some such. So it executes and returns the first row and the first column from a SQL. My thought of this is you use it to grab the result of a count, average, an average that has no group by and so forth. Something that just returns a single value, which typically isn't a result set that you have many rows in. It's a single thing. Count star is probably the most common one, right? And for the demonstration, well, apparently they've been missing in my layout here for some reason. Not sure why. We'll see what happens. I have noticed that when I looked through this before. Or no, here we go. I have missed them all at least. So here is the example then. Start the same way, an empty array of binds, and then we declare a variable tb count, number of tables, and we do a select count star from user tables, and we output the text number of tables plus the result we got from the query, and the result we get out is number of tables, 42. Should be 42, right? That's the right answer to any question. Over to the next function we have to our disposal is execute return list of list. Executes and returns an array rows of arrays row. To some people that may make perfect sense. It doesn't to me. It grabs the result of a select as an array of rows and columns. The array has the column names in index 0. So below here I show an example of how it would be. For the array 0, 0 would be the first column name. 0, 1 would be the second column name. And then over to the first row, which is in 1, 0. That's the first column of the first row. And 1, 1 is then, of course, the second column of the first row returned. So we're going to print the number of tables in the schema. Which is a misnomer, I guess. Anyway, we declare binds, and we declare a bind variable this time, and a table that has an uppercase T in it, or a T in it. So we select the table name, and we select the average row length of it, where the table name is like that bind variable. And then we print out 1 row per table found. So in this case, we get table name and average row length for the two tables. One is called TB, one is USGS custom. If we back up a little bit here to look at this, on this select, the column names was outputted, but why is that? It's back to what I talked about there. How this works, that the 0 index is a row of column names for what was returned. We don't print them hard-coded, we get them from Oracle in this case. And then we have another one that is execute return list. Execute and returns an array of rows of objects row. Again, means really very little to me. That with a proper theoretical knowledge of some technology here, that may make sense, but it does not to me. It grabs the result of a select as an array of rows. That to me makes sense. That's how I usually work. The array in this case does not have column names in the response. So now we refer to it in a different way. We refer to the array as 0.column_name. So in this demonstration, we're gonna basically do what we just did. We're gonna print the tables of the schema. This is identical to what we just did. We use a different function and we see how it behaves differently. Or behaves the same way, but in a slightly different way. So the start here is the same. We declare the bind variable tb with a %t%, right? And then we have the call to this function. Same exact select, no difference whatsoever in that. The difference is rather in the function after, where we have a context.write and we print it by table name, hard-coded or whatever you would like to call it, and average row length, hard-coded. And the output then is similar to before. Now we get on the first one, on this 0, if we go back here, the loop is on 0. So we start on 0 and we count up. So on the very first row in this array, we're gonna find the first table. So it's TB. And USGS custom is 57, has the value 57, which is the average row length. Now, what is different from last time is that we don't have the column names in the output because it wasn't part of the array returned. Instead, we have the column names. We know the column names, so we refer to them by name in the code. Over to get lost exception. This is a function that we use to check how the last query or last call went of all these execute functions. It retrieves the exception, we get the text and so forth. Key thing is that calling it clears it. So once you've seen that you have had an error, if you then go back and you try to print it, it's not there anymore. You have to pick it up and store it in some variable so that you can refer to it. So that's basically the functions that's around those that most things are done. There are more complex things that could be talked about in a more deep dive of advanced ways to do this, but that would have to be another presentation because time will not allow for that kind of work here, and that would maybe be better done face-to-face in a workshop model or some such. Who knows? But let's talk about a little bit more about what we can do when not even JavaScript takes us as far as we want to go. JavaScript is not optimal for everything. Anyone that has worked with it has noticed that for things that is contained within a client, in this case, it's not really a web GUI, but still, within a client, it works fine. But when you get to things where you more interact with things on your computer and such, or manipulate different things that are not GUI based, it becomes not as easy. So an example is reading a file. JavaScript is limited in that because that would be a security concern if a JavaScript could be loaded down to your web browser and then execute and then read a file or write a file on your system. It's restricted from that. Fortunately, since this is Java, it's not just that Java can run a JavaScript thing. The JavaScript can also interact back into Java and reach into the API Java has. And Java, of course, has a full-featured API for just most everything. So you can run some things in a separate thread. An example of this would be that you want to start something that runs in the connection you already have to the database because you logged on in SQLcl, right? But you want to start a query in a second connection to the database, and then you want to monitor what it does, maybe print wait events or something. Let's demonstrate reading a SQL from a file and execute it. Again, it's of course not the way we would execute something in a file. So let's start with the first three things here with the string, files, and paths. It really is just creating a short way to refer to these Java objects in your code. Otherwise, you would have to type everything that's on the right side of the equal sign down in the actual code, and becomes more or less impossible to read then. So we now define a statement we define a variable for a statement that is filled with the data from a set of Java codes here. It's a string. We read the data from a file that's on a certain path, and we remove some white space from it. That's essentially what that line does. And the next thing is that we set the statement by SQLcl. This is what we saw on the very first slide, where we ran select start from dual. Now we set it to another statement, the statement we've read in, and we run it. And in this case, we put a somewhat basic SQL into a file. And this is the output we would expect from it, right? So this is, let's see what we have on this one, or we get into use cases. So this is the same exact thing as would happen if we just did at userobjects.sql, right? It runs the SQL that's in the file. So that's not how we would do this, but it shows how with Java we can do things that are more file level manipulation. We can do things with putting things in different threads, multiple connections, and so forth. It opens up for a lot of very nice features, and you don't have to do very much JavaScript and not very much Java. It's pretty much boilerplate. A lot of the things if you don't get very deep into it. So to finish this up, I've put together a few use cases to give some ideas of what could be done. And in this first one, we just deal with a limitation in what is allowed to be done within a PL/SQL code block. And most everyone has probably worked with multi-tenant database at this point. You move around between your pluggable databases with alter session set container equals the name of the pluggable database or the name of the root container. So you can do this with a PL/SQL procedure, but when you want to go to the root container, cbd $root, it does not work, and I'm not sure it works with the other ones either. I think it works with the other ones, but there's a security issue here, because in a single block of SQL code is compiled in a security framework or security limitation, right? And if you're allowed to move between databases and keep running that code without compiling it in that database, there is no control in really what happens. Right, if you in one database you would do delete from a certain table. If you, when that compiler checked your right to do that, if you then moved to another pluggable database and were allowed to have that delete execute, you could, in theory, run a delete against a table you're not allowed to do, or call a package or some such. So with JavaScript you can do that in a script, and the reason you can do that is that each statement you run is its own statement that runs in the database. It gets called from the client to the database, so the database has a new invocation each time, and therefore you're allowed to do it. So you could make a very short version of this command that was, say, SC and the name of the plug, and it moved you there, and if you said SC ctp $root, you would end up in the root container. Let's see. So the story time here, it's a story time about me, essentially. I had a big problem a while ago. We were looking at a database environment that sometimes worked well, sometimes it didn't, and we ran big tests, and it took us a few hours to run through that test, and afterwards sometimes it was a wasted effort because the performance was not at all what it should be, and we didn't really know what the reason was, and the reason for it isn't really important here. But what we needed was an easy way to gauge if the environment was ready for us to run, or if we had to look for this problem and or wait for it to go away or whatever, right? And a very easy way for us to do this was to see how many times we could run select star from Duo. Well, easy enough to do in SQLcl, right? You put it in and then you just loop through it and you do a gazillion such things. Well, yes, but it doesn't prove the problem, because the problem wasn't inside the database. The problem was in the database environment somewhere. So what we needed to do was from someplace issue that select statement, so that it went through the network and through all the layers, both on the client side and on the database side, and came into database core, ran that, returned back to the client, and then issued it again, and then did as many such we could in a certain time frame. We ended up with 1 minute, but it could be 10 seconds or it could be 5 minutes, doesn't really matter, right? This can of course not be done with SQL, because SQL only runs within the database, has no mechanism for running elsewhere. It would be hard to do in shell script. It could be done, but it would be somewhat hard. And the reason it would be hard to do that is the natural invocation from a shell script is to start SQLcl or SQL Plus or something with a SQL and parse the output. Then it could be done from some other language, but then we're into having a Java developer write code or Python or write it ourselves in those languages, and takes us out of our natural habitat of SQLcl and SQL Developer. So with this, I built, with very little code, a monitoring thing that issued this once a minute. We could see when it was in good shape, and it also ended up being a plug that I could give to people that wanted to test this, and they could move it to whichever application server in our enterprise they wanted. So they could just shoot it out, have it execute, and give them the data. So it becomes a self-contained utility. SQLcl together with this script again, and with a runner script for it, gave them a utility that allowed this to be tested. And in all its simplicity, it's been one of the better indicators of the whole environment's performance in a single certain point. So use case number 3. So if we want to have something that just changes the schema, if as a DBA, or at least if you work out of a account that has a lot of access, you very frequently do an authorization set current schema to point to the correct schema, or even if you just have one account you always log in with, but the application should be using objects in another schema. Every time you log in, you want this to be done, and you may want this function. Now, this can be added to SQLcl by extending the command listener. This is the thing that when you enter something on at the prompt in SQLcl, it looks at what you entered and figures out if there is a command for it, or it tells you that there is no such command. It goes for select, goes for all the different commands that you get up if you type help, right? It checks those, and you can add your own command that behaves like a native command supported by the product. It sounds a bit hard. It's not really not. It's boilerplate. It's on GitLab in where Chris has his things. This exact thing is there. Set schema.js is there, and it shows how it's done, and essentially there's a bit of Java that hooks into their framework and becomes one of the things they call on what gets entered, and you get to evaluate if what's entered is the command you're looking for, and then you just take that, you take the parameters, you do what needs to be done, and that becomes a command that has a native feel in SQLcl when you use it. And here's use case number 4. I was talking a little bit towards this area before. So if we want to set up a new command, we may want to read SQL from a file, want to execute it in a second thread with its own connection to the database. And then ever so often we look at how it's behaving. We can print the wait event, and when it's done, we could even pull down a SQL trace if we started one before and stop it when it's done, and then we could pull it down afterwards and just drop it on a file on your computer, so that no one has to run up on the database server and find that SQL trace. I'll leave that slide up. I want to talk about another use case that I just encountered that I'm currently working on, and that is I want a way to, for Apex, install, to run and figure out sort of things, and the setup of create a user and the table space and so forth. So that's nothing new. That's nothing worth talking about really. But we come down to the Apex application. I want to figure out what version is in the file, the Apex application file, f200.sql or whatever. So I want to parse that out. Then I want to look in the database and see if this application installed. If it's installed, is it the same version? If it's not the same version, I want to install the one that is sitting in my Git repository. So there is a command to run or to load an Apex application. It's part of SQLcl. You can just do it. But there is no way to put logic around that. So if you want to put logic around that and have a flow of things before and after that, you need to put it in some kind of application logic. And a script like this works very well for that. There is a JavaScript hook-in for Apex, installing Apex applications, and you just use it more or less exactly the way you would use the actual command. But with that, we can now put conditions around whether we want to load it or which one we want to load or whatever. So that's another nice way of using this, and in one file have some piece of SQLcl, some piece of a JavaScript script to just do the loading of that application and so forth. And the reason it needs to be that way at all, if you just have one database, it doesn't matter. If you have 200, like I do, you don't want to do it by hand in each one of those and check things with manual SQL commands. Okay, let's talk about the summary of what we've talked about here today. The JavaScript allows for things that SQL and PL/SQL cannot do or cannot easily do. But a lot of it's not possible at all because those things always run in the database, and sometimes you want to have the client side part of it. You can extend SQLcl with any command you're missing. Like I said, you can hook it into the command interpreter to say that, okay, you entered these letters in the beginning. That means that we're gonna perform some functions you've defined. I have used it quite a bit to prove things for Java developers when they tell me that it cannot be done this or that way. So then this is a nice hook-in to be able to do it. You get automatically connections and all of that set up for you. You can just access it and use it, and all you need to do is a couple of lines of Java code for whatever you want to prove or test out. Another way to do it is to simulate how a Java program would behave, right? Because if you write something in PL/SQL, all it does is the PL/SQL side. It does not transfer data over the network to you. It doesn't pick it up. It doesn't put it in Java objects. It doesn't do all of those things. And sometimes to solve performance problems, you need that whole part of the stack to be able to figure out why something takes a long time when it's for you is lightning fast. It allows you to fine-tune SQLcl for your own workflow. Some of the things I mentioned here is you add the commands for what you want to do to shorten commands or invent a whole series of things that needs to happen in certain cases. And it gives you a platform for all your automation needs. You can drive a lot of automation via SQLcl this way. Thought I had one more thing I was going to add to that. We'll skip that, I guess. Now I do not see anything out in the chat, so I'll give it a few seconds if someone wants to write something real fast. Just put a dot or something, and otherwise we will just close this session in a minute. So I think we do that. If there's anything you want to ask or you want to see more of, or have a question about something with this, let me know. If you run into trouble with it, or also let me know. I'm very curious in how other people use this, and if you already have used it, it would also be interesting to hear your case for how you used it and what you got with it. So with that, thank you for tuning in. See you next time. And right before that, I'm going to say that next month is Heli from Finland. We're going to talk about a very impressive Apex application they built. They built an application to do COVID tracing in Finland. So